Here we're going to talk about the Quadratics Chapter, Section C, which is a section that's in HL but is not in SL. Basically, the idea is that if you look at a quadratic function, you can see some relationships between the roots and the coefficients of the standard form ax squared plus bx plus c. And so let's see how that works. I'm just kind of skip over this part at the top because it's not going to make much sense yet, okay? But basically, what we're going to do is we're going to take the roots. Like if we take this and we factor it, we're going to get something like this, right? X minus alpha, x minus beta, where alpha and beta are the roots. Well, it turns out that a alpha plus beta and alpha times beta has a relationship with these three coefficients, and we're going to see what that is. The way we're going to do that is we're going to work backwards. We're going to start with this and see what would be the a, b, and c values for these two roots, alpha and beta. Okay. Okay. So first it says to expand this with FOIL. So if I'm going to expand x minus alpha and x minus beta with FOIL, basically that'll give me x squared for the first term. It'll give me plus alpha beta for the last term because it's negative and negative. And then for the middle terms, I'm going to have minus alpha x and I'm going to have minus beta x, right? If I add all those together, I'm going to get x squared minus alpha plus beta x plus alpha beta. Okay, and just from looking at this, I can already see that some of the what I was looking for. I was looking for alpha plus beta, there it is. I was looking for alpha beta, and there it is. So I can already see where these relationships are going to appear in the standard form. Now I'm going to multiply each term by a. So I'm going to get ax squared minus a alpha plus beta x plus a alpha beta. And you don't know you're supposed to multiply by a, except for I'm telling you to multiply by a, so that's why you know, okay? So don't say, well, how was I supposed to know how to multiply by a? Okay. Okay, then I'm going to take this expression and I'm going to start relating it to the standard form. So first I'm going to say, well, yeah, those two match, a and a match. Then I'm going to say, well, what does B match with? Well, B matches with that big mess here. And C matches with this here, okay? You notice that the x's are not part of the coefficient, so that's why they're not written there, okay? So now I can write that the C coefficient is equal to A times alpha times beta, or if I wanted to put the Roman letters on one side and the Greek letters on the other side, I would divide both sides by a, and I would say C over a is equal to alpha beta. And then for the purple coefficient, I'm going to do something similar. I'm going to say that the B coefficient is equal to negative a times alpha plus beta. So if I divide both sides by negative a, I get negative b over a equals alpha plus beta. So now have I already derived the relationships that I wanted? I have. See, look at that. There you go. And there we go. So that worked, okay? So that's how you do it. You can see it's very easy. You just FOIL the original factored form, and then you multiply by a, and then you immediately have set equal the coefficients, and that's why you discover that relationship. Now let's see what the relationship is good for, although you can see why this is something that they took out of Math SL because it's not really something you have to know, but it's just kind of interesting. Okay, so let's try to use, we just derived these, so we believe they're true. Find the sum and products of the roots of these standard forms. So like for here, I have a equals 3, b equals negative 2, and c equals 7. So I can figure out the sum and products of the roots, although I can't figure out the exact roots immediately, but eventually I can, right? So negative b over a would be negative 2 over 3, which is equal to 2/3. Okay, so alpha plus beta is equal to 2/3. The other thing we know is that the alpha beta is equal to c, which is 7, over a, which is 3. So we know that alpha, the product, is equal to 7/3. Okay? All right, let's look at C. Okay, so we have 5, -6, and -14 as our A, B, and C coefficients. We're going to figure out the sum and product of the roots. Remember, the roots are alpha and beta. Why are they alpha and beta? Because we defined it to be so. At the very beginning of this derivation, we said that alpha and beta are the roots of the standard form. Okay, so let's see. Alpha plus beta is equal to negative b, which is minus 6, which is positive 6, divided by 5. And alpha times beta is equal to c divided by a. So it's negative 14 divided by 5. Okay? All right. That's pretty easy, right? All right, let's look at this. The quadratic equation ax squared minus 6x plus a minus 2 equals 0. Okay. A is not equal to 0, has one root which is double the other. Okay, so it's saying that alpha is equal to 2 times beta, for example. One of the roots is twice the other. Let the roots be alpha and 2 alpha. Okay, oh yeah, we don't need to do that then because they already gave us that beta is equal to 2 alpha, actually. Hence, find the two equations involving alpha. Okay, so what we're going to start with is alpha plus beta equals, of course I don't have these memorized, negative b over a, and alpha times beta is equal to c over a. Okay. Now let's just fill everything in. So we're going to look at this expression, and the first thing we're going to do is we're going to say, well, the a coefficient is a. The b coefficient is -6, and the c coefficient appears to be a minus 2, right? So this is a, this is b, and this is c. I'm going to just plug everything in, and instead of alpha and beta, I'm going to put alpha and 2 alpha. So I'm going to have alpha plus 2 alpha equals negative 6, which is 6, divided by a, which is a. And then here I have alpha times 2 alpha. Instead of beta, it will be 2 alpha squared equals c, which is a minus 2, divided by a. It says to find two equations involving alpha. We basically are there. We could simplify this one to 3 alpha equals 6 divided by a, right? And then this one here is pretty much as simple as we can get. So now we have two equations and two unknowns, alpha and a. So if you have two equations and two unknowns, you can use algebra, substitution method, or something to figure out part B, which is saying find out what a is, find out what alpha and beta are. Remember, beta is just 2 alpha. So basically it says find a and find alpha. So we can do that by doing substitution method. So first thing I'm going to do is I'm going to say, okay, let's see, alpha is equal to, I could have simplified this a little bit more, right? 3 alpha is equal to alpha equals 2 over a, 2, right? Okay. Then I'm going to take alpha equals 2 over a, and then I'm going to put it in the other equation. So I'm going to have 2 alpha squared equals a minus 2 divided by a. I'm going to put 2 over a in for alpha. Okay? Then I'm going to have 2 times 4 over a squared equals a minus 2 divided by a. And so that would be equal to 8 over a squared equals a minus 2 divided by a. Now I can, let's see, I can cross multiply, right? I'll have 8a equals a cubed minus 2a squared. Is that right? Okay. And then, since they said that a is not equal to 0, I can divide everything by a. And then I will get a quadratic instead of a cubic equation. Okay, now I'm going to rearrange it. So I'm going to have a squared minus 2a minus 8 equals 0. And now I'm going to factor it. So I think it's a minus 4 and a plus 2 equals 0. Is that right? Let me check that. So negative 4 times 2 is negative 8. Negative 4 times a is negative 4. 2 times a is 2a. And yeah, that worked out. So if a minus 4 times a plus 2 is equal to 0, that means a is equal to 4 or negative 2. And what's the value for alpha then? Well, remember, alpha is equal to 2 over a. So alpha could be 2 over 4, or 2 divided by negative 2, which is equal to negative 1. So it would be either 1/2 or negative 1. So those are the possible sets of solutions. Either a equals 4 and alpha equals 1/2, or a equals negative 2 and alpha equals negative 1. Okay, and what's the other root? Well, the other root would be 2 alpha. So the beta root would simply be 1 or negative 2. Okay, all right. Number 5. The roots of the equation x squared minus 6x plus 7 equals 0 are alpha and beta. Find the simplest quadratic equation with the roots alpha plus 1 over beta and beta plus 1 over alpha. Well, now this is not an easy problem. I paused this video and I thought about it for a while, so that's why I can give you the answer now, okay? This has 2 directions you're going to go in. One is you look at this and you're like, okay, I can do this similar to what I did before. Since I know what a, b, and c are, I can figure out that alpha times beta is actually equal to c, which is 7, divided by a, which is 1. So basically it's equal to 7, right? And I also know that alpha plus beta is equal to negative b over a, which would be negative 6, which would be 6 divided by 1 is 6, okay? And then you might think, okay, I'm going to try to simplify that or solve for alpha and beta or something, but actually you don't want to do that, okay? And you don't know that, but if you start doing it, then you'll realize that it was unnecessary, okay? Next thing we're going to do is we're going to look at this, and you have alpha plus 1 over beta and beta plus 1 over alpha. They say that those are the roots of another quadratic equation, which you don't even know what the a, b, and c are yet, which is really confusing because alpha and beta are the roots of this first equation. But actually, if you rearrange alpha and beta, you can make roots for another equation, okay? So we don't know what that equation is yet, but let's figure out what it would be, okay? So we do know that if you do have a pair of roots, that you can put them in the equations alpha beta equals c over a and alpha plus beta equals negative b over a. So let's do that, even though we don't know exactly what's going to happen. So first of all, we could say that the 2 roots multiplied together, alpha plus 1 over beta and beta plus 1 over alpha, if we multiply the roots together, that gives us c over a, right? Of the new equation, not this c over a. We're talking about c over a for a quadratic equation that we don't even know what it is yet. It's the simplest quadratic equation with these roots, okay? And then the other possibility is that we can use the alpha plus beta equation, and if we use the alpha the 2 roots added to each other equation, and if we do that, If we add those together, it gives us negative b over a. Not this negative b over a. We're talking about a negative b over a for a quadratic equation that we haven't defined yet, okay? Now we're going to see if we can simplify this a little bit. Let's do FOIL on this. So we'll get alpha beta for the first term. We'll get 1 over alpha beta for the last term. And then the middle terms will get 1 over beta times beta is 1. 1 over alpha times alpha is 1. So actually the middle term turns out to be 1 plus 1, which is 2. Okay, that's pretty weird. Oh, look at that. Alpha times beta is 7. Plus 2 plus 1 over alpha beta would be 1 over 7, right? So if we add these up, it would be 9 plus 1/7, which would basically be 64 sevenths over C over A, okay? So that's one relationship that we've figured out, and you can see that we never had to actually figure out what alpha and beta were. We used it as is here, because it turned out to be a math trick, okay? And now we're going to try to simplify this. We're going to try to get it in the form where we have alphas times betas, because we don't have alpha plus beta here. We don't have alpha times beta here. We want to get in the form alpha times beta. So what if we multiplied every single term by alpha beta? So we're going to multiply the left side by alpha beta. We're going to multiply the right side by alpha beta. So we're going to get alpha times alpha beta plus 1 over beta times alpha beta would be alpha, right? And beta times alpha beta would be beta times alpha beta. Alpha beta times 1 over alpha would be beta. And you may say, why did you multiply by alpha beta? Because, you know, nobody likes fractions. And here we have two fractions that we better get rid of if we ever going to figure out what's going on. That's why we multiply by alpha and beta, because those are denominators in our fractions. And then we also multiply the right side by alpha beta, because you can't multiply the left side by alpha beta without multiplying the right side by alpha beta too, right? Okay, and now we know alpha times beta is 7, right? So this is 7, this is 7. Let's rearrange it so that 7 alpha plus 7 beta plus alpha plus beta, okay? And negative b over a, alpha plus beta is 7 also, right? Now let's factor out the 7. So now we have, oh, actually we don't need to factor out. We can just add everything up. 8 alpha plus 8 beta is equal to negative 7b over a. And let's factor out the 8. Alpha plus beta is equal to 8 times, let's see, alpha plus beta was what again? It's 6. So it's 8 times 6, which is 48. So we know that 48 is equal to negative 7b over a. So actually, negative b over a is equal to 48 divided by 7. Oops. Okay. I seem to see a pattern here. Do you see how the a value here appears to might be 7 and the a value here might be 7? Okay, so if the a value is 7, that means the c value is 64 and the b value is negative 48. So we just figured it out, right? Now that is one possible answer. They said the simplest answer, so that's the simplest one, right? X squared minus 48x. And c value is 64. Okay. So that is the quadratic equation, simplest possible quadratic equation with those roots. Okay. Why is it the simplest? Because the 7, negative 48, and 64 are coefficients which they're all integers and it can't be reduced. So that's why maybe it's simplest. But if you got any answer, I would be impressed. Okay, Now let's look at this next one. So here we have a as k, we have b as k plus 2, and we have c as negative 3. And let's see what we're going to do. Roots that are real and positive, find the possible values that k may have. Okay, to make the roots real and positive. Well, of course, we're going to use the equations alpha plus beta equals negative b over a. And alpha times beta is equal to c over a. And so we know that c is equal to negative 3 and a is equal to k. And we know that negative b is equal to k plus 2, negative k plus 2 actually, divided by k. Okay, and if we look at these two, we can see that we know that alpha and beta are both supposed to be positive, right? So if you add two positive numbers together, you get another positive number, right? So one of the things we know about k is, or k plus 2 over negative k, is that k plus 2 over negative k is also a positive number, okay? Greater than 0. One thing we know about alpha beta equals negative 3 over k is since k is also a positive, or alpha and beta are also positive numbers, when you multiply two positive numbers together, you also get a positive number. So negative 3 over k is also a positive number. Now what we're going to do is use sign diagrams to figure out what values of k make these true. So first of all, for this left one here, the critical values for the sign diagram are going to be the zeros and whatever legal values there are, asymptotes. So the asymptote here would be k equals 0, right? So we're going to put an asymptote at k equals 0. We're looking for k here, not for x. And the 0 value would be k equals negative 2, so we'll mark that too. Okay? And then in between these three intervals here, what would be the value of the expression? Okay, so let's take a value over here like negative 100. So if we put negative 100 here, we'd have negative 98 on top, and we'd have positive 100 on the bottom, so that would be a negative number. Okay. If we take the value negative 1, which is right between negative 2 and 0, we would get a positive value on top and a positive value on the bottom because we'd have positive 1 divided by positive 1. And if we put like positive 100 in there, it would be like 102 divided by negative 100, so that would be a negative number. Okay. So we got negatives on the left, we got negatives on the right, and only between negative 2 and 0, we're going to have a positive number. So basically, the range for k that would give us, which would make the above true, would be k is greater than negative 2 and k is less than 0. Okay, let's go to the next one. So negative 3 over k, there are no zeros for that, but there is a critical value, which is the asymptote at k equals 0, right? What about a negative value for k? A negative value of k would be negative 3 divided by a negative value for k, which would be positive. And then positive value for k would give us a negative. So in this case, what would make this true is k is less than 0. Okay. It's kind of repeating what we see here, so it didn't really give us any additional information. Okay, last of all, we haven't used the information yet that the roots are real. Remember, when the roots are real, that means that the discriminant is greater than or equal to 0, right? And let's see, we know that the discriminant is b squared minus 4ac. So what we're saying is that b squared minus 4ac is greater than or equal to 0. So I bet we can write that using k plus 2 and negative 3. So let's do b squared, which is k plus 2 squared, minus 4 times k, which is a is 4, times c, which is negative 3. So basically we have k squared plus 4k plus 4 plus 12k is greater than or equal to 0. And now we can put our b terms together because 4k and 12k can be added together. So we'll have k squared plus 16k plus 4 is greater than or equal to 0. So this actually does not have real roots, so you can't factor it. So why don't we do the quadratic formula? In fact, why don't we just use poly-SMLT, because you already know how to use the quadratic formula. We can't waste any time on quadratic formula. So the coefficients are 1, 16, and 4. So we put 1, 16, and 4. And if you have never used poly-SMLT before, yeah, it's magic, huh? So we got negative 15.7 and negative 2.54. So we got negative 15.7 and we have negative 0.254. These are the two values of k which make the roots 0. So we're going to make one last sign diagram where we have negative 15.7 and we have negative 0.254. And we can see that if we have a really negative value of k, that it's going to be positive. And a really positive value of k is also going to be positive, and in between it's going to be negative. Okay, so the values of k which would make things positive would be here and here. But you can see that we already defined k to be between negative 2 and 0. So basically what that says is it has to be kind of around here. So the left boundary is going to be negative 0.254 and the right boundary is going to be 0, right? So it turns out that the combining all three of these answers, this doesn't really add anything, but combining these three conditions, the final condition would be that k is greater than or equal to negative 0.254. Why greater than or equal to? Because as long as k is exactly negative 0.254 or greater, then the roots are real, and that's what we wanted, right? And the k has to be less than 0. And actually, this negative 2.54, it's actually an irrational number, negative 8 plus square root of 60. So this isn't exactly right here, but I didn't really want you to waste a lot of time doing quadratic formula here, since you're already great at it, right?